Okay guys, in this video we're going to be looking at how we can very easily write a rule to determine the value of the nth term of an arithmetic sequence. And so I want you to consider that because arithmetic sequences are so well behaved, it would really only be a circumstance that we would need the very first number in the entire sequence. So say our first number happens to be 4, and we had a common difference here. Say I have a common difference of 2, so it would tell me what I'm going up or down by every time. You could see how it would be very easy to come up with all of the terms of a sequence so long as you knew two things: the value of the first term and kind of what it's changing by. And so that's what we're going to look at here, is how we can use this rule right here to determine the common rule for the nth term of a sequence that's arithmetic. And so we're going to look at this and interpret what we see here. So it says an is equal to a1 plus d times n minus 1. And so to put this into perspective, what we're saying is the value of the nth term is equal to the value of the first term plus what we're changing by, or the common difference every time, times this quantity n minus 1. And if we arrange things this way, then we would have, say, a rule or a model for the value of the nth term. So one thing I do want to say here is this: when it comes to writing the rule for the nth term, we only really need to know the value of the common difference and the first term. So we're going to write a little grocery list here. The needs: we need the first term value, and we say that this is a1, and we need the common difference, or what it's going up or down by between terms every time. And so this common difference, we use the letter D to denote this. And so let's take a look at how we can use this rule to very easily write the rule for the nth term of a sequence. Excuse me. So down here you'll see it says write the rule for the nth term of the following arithmetic sequences. Now we are going to use this rule that you see right here. It's just that right here the formatting is again off. And so I'm going to rewrite this really quickly here. To write the rule for the nth term of an arithmetic sequence, you just start at your first term and you go up or down by d, and then we have to multiply this by n minus 1. So for this first sequence here, I want you to remember that we can write this so long as we know two things: the value of the first term and the common difference. So very quickly here, let's do this. Let's find our common difference from term to term. Looks like it's going up by 2 every time, but we can get this by taking a term like -3 and subtracting the term right before it. So we get 2 is our value of d here. And if a1 has a value of -5, then I'm going to show my work over here. We're going to write that the rule for the nth term is equal to the value of my first term, so -5, plus d, which is +2, times n minus 1. Now I'm going to put a box around this and say right now, or tell you right now, that this is the rule for the nth term. However, it is very common practice for us to go ahead and distribute the d value now that we have this rule, and so we would get -5 plus 2n minus 2. And then what we would do is just finish up by combining like terms on those constants there. And so what we get for a final rule is really 2n, and it looks like it would be -7. So I do want to show you this here, that this would be the rule for this sequence, and it looks like if we've got 1, 2, 3, 4, 5 terms, what would be the value of the sixth term if we use this rule? We could see that it'd be 2 times 6 minus 7, which is 12 minus 7, which is 5, which as I look up here, looks like 5 should come next in the sequence. So let's take a look at letter B here. And letter B should be saying this. It says A1 has a value of 10 and D has a value of -1.5. And so if we were to look at what the sequence really is, it's this sequence where we have 10 and then it goes down by 1.5, so it goes to 8.5, and it goes down by another 1.5, so it goes to 7, and then 5.5, and so on and so forth. What we want to do is write a rule for this. And so again, because it's arithmetic, let's go ahead and identify two things: the value of the first term, so we say a1 is 10, and d is -1.5. Then our rule would have to be, again, starting at your first term, a1 plus d -1.5 times n minus 1. And just like we did with the last expression, we're going to say then our nth term is the value of our first term plus, let's distribute this, we get a -1.5n plus 1.5, when we take a -1.5 times a -1, it's positive. And if we combine like terms here, we get then the value of the nth term is equal to -1.5n plus 11.5. And this should be able to successfully predict the value of any term in the nth position. Okay, so for our last one, we're going to write a rule for here. It's kind of a verbal model, but I want you to see that this is very much an arithmetic case. It says a person starts a new job with a bonus of $1,000 and then makes $3,000 per month more after that. Write a rule that describes the amount of money the person has at any given month. And so when we look at our initial value here, we can interpret this as being like our $1,000 that we start with here, and then it's going up by $3,000 every month past that. And so our common difference between terms really is 3,000. So if we want to write a rule that describes the amount of money a person has, which is the AN part, at any given month N, then we would say that our rule would be the first term value, the $1,000 we start with, plus the $3,000 we're making per month, times n minus 1. And so as we typically do, let's go ahead and distribute our 3,000. We would have, AN is 1,000 plus 3,000 n minus 3,000. And this would simplify to 3,000 n minus 2,000. And so with a rule like this, we would be able to use this to predict how much money we would have at any given number of months after our very first month there. But this is our really quick way of writing rules for arithmetic sequences, and it works 100% of the time. Love it. Cheers.